They move into the green tunnel of overarching palms leading towards the main visitor building. Everywhere, extensive and elaborate planting emphasize the feeling that they're entering a new world, a prehistoric tropical world, and leaving the normal world behind. They look pretty good. Yes, Grant said. I want to see them up close. I want to lift their toe paws and inspect their claws and feel their skin and open their jaws to have a look at their teeth. Until then, I don't know for sure. But yes, they look good. I suppose it changes your feel a bit, Malcom said. Grant shook his head. It changes everything, he said. For 150 years, ever since the discovery of gigantic animal bones in Europe, the study of dinosaurs had been an exercise of scientific deduction. Paleontology was essential detective work, reaching for clues in the fossil bone and the trackways of long-vanished giants. The best paleontologists were the ones who could make the most clever deductions, and all the great dispute of paleontology were carried out in this fashion, including the bitter debate in which Grant was a key figure, about whether dinosaurs were warm-blooded. Scientists have always classified dinosaurs as reptiles, cold-blooded creatures, drawing the heat they needed for life from the environment. A mammal could metabolize food to produce bodily warmth, but a reptile could not. Eventually, a handful of researchers, led chiefly by John Ostrom and Robert Baker at Yale, began to suspect that the concept of sluggish, cold-blooded dinosaurs were inadequate to explain the fossil record. In classic deduction factions, they drew conclusions from several lines of evidence. Thus, dinosaurs' postures suggested warm-bloodedness. They studied trackways, fossil footprints left in mud, and concluded that dinosaurs ran as fast as a man. Such activity implied warm-blooded. They found dinosaur remains above the Arctic Circle in a frigid environment unimaginable for a reptile. And the new studies of group behavior, based largely on Grant's own work, suggested that dinosaurs had complex social life and reared their young, as reptiles did not. Crocodiles and turtles abandoned their eggs, but dinosaurs probably not. The warm-blooded controversy had raged for 15 years, before a new perception of dinosaurs as quick-moving, active animals was accepted, but not without lasting animosities. At conventions, there were still colleagues who did not speak to one another. But now, if a dinosaur could be cloned, why? Grant's field of studies was going to change instantly. The paleontological study of dinosaurs were finished. The whole enterprise, the museum halls with their giant skeletons and flock of echoing school children, the university laboratories with their bone trays, the research papers, the journals, all of it was going to end. You don't seem upset, Malcom said. Grant shook his head. It's been discussed in the field. Many people imagined it was coming, but not so soon. Stories of our species, Malcom said, laughing. Everyone knows it's coming, but not so soon. My only question is where they get the DNA. Grant was aware of a serious speculation in laboratories in Berkeley, Tokyo, and London that it might eventually be possible to clone an extinct animal such as a dinosaur. If you could get some dinosaur DNA to work with. The problem was that all known dinosaurs were fossils, and the fossilization destroyed most DNA, replacing it with an inorganic material. Of course, if a dinosaur was frozen, or preserved in a bin dung, or mummified in a desert environment, then its DNA might be recoverable. But nobody has ever found a frozen or mummified dinosaur, so cloning was therefore impossible. There was nothing to clone from. All the modern genetic technology was useless, and it was like having an XORed copy, but nothing to copy with it. You can't reproduce a real dinosaur, because you can't get a real dinosaur DNA, unless there's a way we haven't thought of, Grant said. Like what? I don't know. Beyond the fence, they came to a swimming pool, which spilled over into a series of waterfalls and small rocky pools. The area was planted with huge ferns. Isn't this extraordinary? Regis said. Especially in this misty day, these plants really contribute to the prehistoric atmosphere. These are authentic prehistoric ferns, of course. Ellie paused to look more closely at the ferns. Yes, it was just as he said. Serena vertiformans, a plant found abundantly in fossils more than 200 million years old, now common only in the wetlands of Brazil and Colombia. But whoever had decided to plant these particular ferns at the pool site obviously didn't know that the spores of vertiformis contain a deadly beta-carboline alkaloid. Even touching the attractive green ferns could make you sick. If a child were to take a mouthful, he would almost certainly die. The toxin was 50 times more poisonous than olander. People were so naive about plants, Ellie thought. They just choose plants for appearance, as they would choose a picture for the wall. It never occurred to them that plants were actually living things, busily performing all the living functions of respiration, injections, excretion, reproduction, and defense. But if planting deadly ferns at a pool site was any indication, then it was clear that the designer of Jurassic Park had not been as careful as they should have been. "Isn't it just wonderful?" Regis was saying. "If you look up ahead, you'll see our safari lodge." Ellie saw a dramatic, low building with a series of glass pyramids in the roof. "That's where you'll all be staying here in Jurassic Park." Grant's suit was done in the Beijing tones, the rattan furniture and green jungle paint motifs. The room wasn't quite finished. There were stakes of lumber in the closets, and pieces of electrical conduits on the floor. There was a television set in the corner, with a card on top. He found the names irritably cute. Grant turned on the television, but got only static. He shut it off and went into his bedroom, tossed his suitcase on the bed. Directly over the bed was a large pyramidal skylight. It created a tented feeling, like sleeping under the stars. Unfortunately, the glass had been protected by heavy bars, so that striped shadows fell across the bed. Grant paused. He had seen the plants from the lodge, and he didn't remember bars on the skylight. In fact, these bars appeared to be rather crude addition. A black steel frame had been constructed outside the glass wall, and the bars welded to the frame. Puzzled, Grant moved from the bedroom to the living room. His window locked out on the swimming pool. "By the way, those ferns are poisonous," Ellie said, walking into his room. "But did you notice anything about the rooms, Alan? They changed the plans." "I think so, yes. The windows are small, and the glass is tempered set in a steel frame. The doors are steel-clad. That shouldn't be necessary. And did you see the fences when we came in?" Grant nodded. The entire lodge was enclosed within a fence, with bars of inch-thick steel. The fence was gracefully landscaped and painted flat black to resemble worth iron, but non-cosmetic effort could disguise the thickness of the metal or its 12-foot height. "I don't think the fence was in the plans either," Ellie said. "It looks to me like they turned this place into a fortress." Grant looked at his watch. "We'll be sure to ask. The tour starts in 20 minutes. There was a small auditorium dominated by a robot Tyrannosaurus Rex, posing menacingly by the entrance to an exhibit area labeled "When Dinosaurs Ruled the Earth." Further on were other displays, "What is a Dinosaur?" and "The Mesozoic World." But the exhibits weren't completed. There were wires and cables all over the floor. Gennaro climbed up on the stage and talked to Grant, Ellie, and Malcom, his voice echoing slightly in the room. Hammond sat in the back, his hands folded across his chest. "We're about to tour the facilities," Gennaro said. "I'm sure Mr. Hammond and his staff will show everything in the best light. Before we go, I want to review why we are here, and what I need to decide before we leave. Basically, as you all realize by now, this is an island in which genetically engineered dinosaurs have been allowed to move in a natural park-like setting, forming a tourist attraction. The attraction isn't open to tourists yet, but it will be in a year. Now, my question for you is a simple one. Is this island safe? Is it safe for visitors? And is it safely containing the dinosaurs?" There are two pieces of evidence in which we have to deal with. First of all, there is Dr. Grant's identification of a previous unknown dinosaur on the Costa Rican mainland. This dinosaur is known only from a partial fragment. It was found in July of this year, after it supposedly bit an American girl on the beach. Dr. Grant can tell you more later. I have asked for the original fragment, which is in a lab in New York, to be flown here so that we can inspect it directly. Meanwhile, there is a second piece of evidence. Costa Rica has an excellent medical service, and it tracks all kinds of data. Beginning in March, there are reports of lizard biting infants in their cribs, and also, I might add, biting old people who were sleeping soundly. These lizard bites were reportedly reported in coastal villages from Ismailoya to Punta Arenas. After March, Lizard bites were no longer reported. However, I have this graph from the Public Health Service in San Jose of infant mortality in the towns of the West Coast earlier this year. I direct your attention to two features of this graph, Gennaro said. First, infant mortality is low in the months of January and February, then spikes in March, then it's low again in April. But from May onward, it is high, right through July, the month the American girl was bitten. The Public Health Service feels that something is now affecting the infant mortality and is not being reported by the workers in the coastal villages. The second feature is the puzzling B-weakling spiking, which seems to suggest some kind of altering phenomenon as it work. Alright, Gennaro said. That's the evidence I want to explain. Now are there any... We can save ourselves a great deal of trouble, Malcom said. I'll explain it for you now. You will? Gennaro said. Yes. First of all, animals have very likely gotten off the island. Oh, balls. And second, the graph from the Public Health Service is also certainly unrelated to any animals that have escaped. How do you know that? You'll notice that the graph alternates between high and low spikes, Malcom said. That is characteristic of many complex systems. For example, water dripping from a tap. If you turn on the faucet just a little, you get a constant drip, drip, drip. But if you open it a little more, so that there's a bit of turbulence in the flow, then you'll get an alternate larger and small drops. Drip, 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 drip. Like that. You can try it yourself. Turbulence produces alteration. It's a signature. And you will get an alternating graph like this for the spread of any new illnesses on the community. But why do you say it isn't caused by escaping dinosaurs? Grant said. Because it is non-linear signature, Malcom said. You need 100 of escaped dinosaurs to cause it. And I don't think 100 of dinosaurs have escaped. So I concluded that some other phenomenon, such as a new variety of flu, is causing the fluctuation you see in the graphs. But you think the dinosaurs have escaped? Probably yes. Why? Because of what you're attempting here. Look, this island is an attempt to recreate a natural environment from the past, to make an isolated world where extinct creatures roam freely, correct? Yes. But from my point of view, such an undertaking is impossible. The mathematics are so self-evident that they don't need to be calculated. It's rather like my asking you whether on $1 billion incoming, you had to pay tax. You wouldn't need to pull out your calculators to check. You would know tax was owned. And similarly, I know overwhelmingly that one cannot successfully duplicate nature in this way, or hope to isolate it. Why not? After all, there are zoos. Zoos don't recreate nature, Malcom said. Let's be clear. Zoos take the nature that already existed and modify it very slightly to create holding pens for animals. Even though minimal modifications often fail, the animals escape with regularity. But a zoo is not modeled for this park. This park is attempting something far more ambitious than that, something much more akin to making a space station on Earth. Gennaro shook his head. I don't understand. Well, it's very simple. Except for the air, which flows freely. Everything about this park is meant to be isolated. Nothing gets in, nothing out. The animals kept here are never to mix with the greater ecosystem of Earth. They are never to escape. And they never have, Hammond snorted. Such isolation is impossible. It simply cannot be done. It can. It's done all the time. I beg your pardon, but you don't know what you're talking about. You arrogant little snot, Hammond said. He stood and walked out of the room. Gentlemen, Gennaro said. I'm sorry, Malcom said, but the point remains. What we call nature is in fact a complex system of far greater substantially than we are willing to accept. We make a simplified image of nature, and then we butch it up. I'm no environmentalist, but you have to understand what you don't understand. How many times must the point be made? How many times we must see the evidence? We'll build the Aswa Dam and claim it is going to revitalize the country. Instead, it destroys the fertile Nile Delta, produces parasitic infestations, and wrecks the Egyptian economy. Excuse me, Gennaro said, but I think I hear the helicopter. That's probably the sample for Dr. Grant to look at it. You did what? You invited who? Take it easy, Hammond said.
Are you out of your goddamn mind? Now look here, I think we have to get something clear. No, you get something clear. This is not a social outing. This is not a weekend excursion. This is my island, Hammond said. And I can invite whomever I want. This is a serious investigation of your island because your investors are concerned that it's out of control. We think this is a very dangerous place and you're not going to shut me down, Donald. I will if I have to. This is a safe place, no matter what that damn mathematician is saying. It's not, and I'll demonstrate it safely. And I want you to put them back on the helicopter. Can't. It's already leaving. God damn it. Don't you see you're needlessly risking... Let's continue this later. I don't want to upset the children. Grant turned and saw two children coming down the hillside, led by Regis. There was a bespectacled boy of about 11, and a girl a few years younger, perhaps 7 or 8. Her blonde hair pushed up under the Med's baseball cap, and a baseball glove slung over her shoulder. The two kids made their way nimbly down the path from the helipad, and stopped some distance from Gennaro and Hammond. Christ. Now take it easy. Their parents are getting a divorce, and I want them to have a fun weekend here.
Tim Murphy could see at once that something was wrong. His grandfather was in the middle of an argument with a younger man, red-faced man opposing him. On the other adults standing behind him looked embarrassed and uncomfortable. Alexa felt the tension too, because she hummed back, tossing her baseball in the air. Go on, Lex. Go on yourself, Timmy. Don't be a worm. I'll introduce you to everyone, and then we can take the tour. I have to go, Lex said. I'll just introduce you first, Regis said. No, I have to go. But Regis was already making introductions. First to Grandpa, who kissed both of them, and then to the man he was arguing with. This man was muscular, and his name was Gennaro. The rest of the introductions were blurred to Tim. There was a blonde woman wearing shorts, and a man with a beard who wore jeans and a Hawaiian shirt. He looked like an outdoors person. Then a fat college kid who had something to do with computers. And finally a thin man in black, who didn't shake hands, but just nodded his head. Tim was trying to organize his impressions, and was looking at the blonde woman's legs, when he suddenly realized that he knew who was the bearded man was. Your mouth is open, Lex said. I know. Oh, sure. You just met him. No, I have his book. What book is that, Tim? Lost World of the Dinosaurs, Tim said. Daddy said Tim has dinosaurs in his brain. Dinosaurs on the brain? The bearded man said. Well, as a matter of fact, I have the same problem. Dad says dinosaurs are really stupid. He said Tim should get out in the air and play more sports. Tim felt embarrassed. I thought you had to go. In a minute, Lex said. I thought you were in such a rush. I'm the one who would know. Don't you think, Tim Murphy? She said, putting her hands on her hips, copying her mother's most irritating stance. Tell you what, Regis said. Why don't we all just head on over to the visitor center, and we can begin our tour. How old are you, Tim? 11. And how long have you been interested in dinosaurs? Grant asked. A while now, he said. He felt nervous to be talking to Dr. Grant. We go to museums sometimes, when I can talk my family into it. My father. Your father's not especially interested? Tim nodded and told Grant about his family's last trip to the Museum of Natural History.
His father had looked at his skeleton and said, "That's a big one."
No, Dad, that's a medium-sized one. A Camptosaurus.
Oh, I don't know. Looks pretty big to me.
It's not even full-grown, Dad.
His father squinted at the skeleton. What is it, Jurassic?
Geez, no, Cretaceous.
Cretaceous? What's the difference between Cretaceous and Jurassic?
Only about 100 million years, Tim said.
Cretaceous is older?
No, Dad, Jurassic is older.
Well, his father said, stepping back, it looks pretty damn big to me. And he turned to Tim for agreement. Tim knew he had better agree with his father, so he just muttered something. And they went to another exhibit. Tim stood in front of one skeleton, a Tyrannosaurus rex, the mightiest predator the Earth had ever known for a long time. Finally, his father said, "What are you looking at?"
I'm counting the vertebrae, Tim said.
The vertebrae?
In the backbone.
I know what vertebrae are, his father said, annoyed. He stood there a while longer, and then he said, Why are you counting them?
I think they're wrong. Tyrannosaurs should only have 37 vertebrae in the tail. This has more.
You mean to tell me, his father said, that the Museum of Natural History has a skeleton that's wrong? I can't believe that.
It's wrong, Tim said. His father stomped off towards a guard in the corner. What did you do now? His mother said to Tim. I didn't do anything, Tim said. I just said the dinosaur is wrong, that's all.
And then his father came back with a funny look on his face, because of course the guard told him that the vertebrae in the tail. How'd you know that? His father asked.
I read it, Tim said.
That's pretty amazing, son, he said, and he put his hand on his shoulder, giving it a squeeze. You know how many vertebrae belong in that tail. I've never seen anything like it. You really do have dinosaurs on the brain. And then his father said he wanted to catch the last half of the Mets game on TV, and Lex said she did too, so they left the museum. And Tim didn't see any other dinosaurs, which was why they had come there in the first place. But that was how things happened in his family. How things used to happen in his family, Tim corrected himself. Now that his father was getting a divorce from his mother, things would probably be different. His father had already moved out, and even though it was weird at first, Tim liked it. He thought his mother had a boyfriend, but he couldn't be sure, and of course he would never mention it to Lex. Lex was heartbroken to be separated from her father, and in the last few weeks she had become so obnoxious that...
Was it 5,027? Grant said. I'm sorry? The Tyrannosaur at the museum. Was it 5,027? Yes. How did you know? Grant smiled. They had been talking about fixing it for years, but now it may never happen. Why is that? Because of what is taking place here on your grandfather's island. Tim shook his head. He didn't understand what Grant was talking about. My mom said it was just a resort, you know, with swimming and tennis. Not exactly, Grant said. I'll explain as we walk along. Now I'm the damn babysitter, Ed Regis thought unhappily, tapping his foot as he waited in the visitor center. Ed Regis didn't like it at all. He felt degraded. He wasn't a damn babysitter. And for that matter, he wasn't a damn tour guide. Even for our VIPs, he was the head of the public relations for Jurassic Park, and he had much to prepare between now and the opening, a year away, just to coordinate with the PR firms in San Francisco and London, and the agencies in New York and Tokyo. Was full-time job, especially since the agencies couldn't yet be told what the resort's real attraction was. The firms were all designing teaser campaigns, nothing specific, and they were unhappy. Creative people needed nurturing. They needed encouragement to do their best work. He couldn't waste his time taking scientists on tours. Alright folks, let's begin our tour on the second floor. Tim went with the others, following Mr. Regis up the black suspension staircase to the second floor of the building. Tim felt a thrill when he saw that sign. They walked down the second floor hallway. One wall was glass, looking out into the balcony with palm trees into the light mist. On the other wall was stenciling doors, like offices, park warden, guest service, general manager. Halfway down the corridor, they came to a glass partition marked with another sign. Never mind the signs. They're just up for legal reasons. I can assure you everything is perfectly fine. He led them through a door. There was a guard on the other side. Ed Regis turned to the group. You may have noticed that we have a minimum of personnel on the island. We can run this resort with only a total of 20 people. Of course, we'll have more when we have guests here, but at the moment there's only 20. Here's our control room. The entire park is controlled from here. The man on the left is our chief engineer, John Arnold. Regis pointing to a thin man on a bottom-down short-sleeved shirt and tie, smoking a cigar. And next to him is our park warden, Mr. Robert Muldoon, the famous white hunter from Nairobi. Muldoon was a burly man in khaki, sunglasses dangling from his shirt pocket. He glanced at the group, gave a brief nod, and turned back to the computer screen.
I'm sure you want to see this room, but first, let's see how we obtain dinosaur DNA. The sign on the door says extraction, and like all the doors in the laboratory building, it opened with a security card. Inside, Tim saw a small room bathed in green light. 4 technicians in the lab coats were peering into a double-barreled sterile microscopics, or looking at an image on a high-resolution video screen. The room was filled with yellow stone. The stones were glass shelves, in cardboard boxes, in large pull-out trays. Each stone was tagged and numbered in black ink. Regis introduced Henry Wu, a slender man in his 30s. Dr. Wu is our chief geneticist. I'll let him explain what we do here. Henry Wu smiled. At least I'll try, he said. Genetic is a bit complicated. But you're probably wondering where our dinosaur DNA comes from. It crossed my mind, Grant said. As a matter of fact, there are 2 possible sources. Using a low antibody extraction technique, we can sometimes get DNA directly from dinosaur bones. What kind of yield? Grant asked. Well, most cellular proteins is leached out during fossilization, but 20% of proteins are still recoverable by gritting up the bones and using Lloyd's procedure. Dr. Lloyd himself has used it to obtain proteins from an extinct Australian marsupials, as well as blood cells from ancient human remains. His technique was so refined it can work with mere 50 nanograms of material. That's 50 billion tons of a gram. And you have adapted his technique here? Only as a backup, Wu said. As you can imagine, a 20% yield is insufficient for our work. We need an entire dinosaur DNA strand in order to clone. And we get it here. From ember, the fossilized resin of a prehistoric tree sap. Grant looked at Ellie, then at Malcom. That's really quite clever, Malcom said, nodding. I still don't understand, Grant admitted. Tree sap often flow over insects and trap them. The insects are then perfectly preserved within the fossils. One finds all kinds of insects in amber, including bitten insects that have sucked the blood from a large animals. Sucked the blood? You mean suck the blood of dinosaurs? Hopefully, yes. And then the insects are preserving the amber. Grant shook his head. I'll be damned. That just might work. I assure you, it does work, Wu said. If this insect had any foreign blood cells, we may be able to extract them and obtain paleo DNA, the DNA of an extinct creature. We wouldn't know for sure, of course, until we extract whatever is in there, replicate it, and test it. That is what we have been doing for 5 years now. It has been a long, slow process, but it has paid off. Actually, dinosaur DNA is somewhat easier to extract by this procedure than mammalian DNA. The reason is that mammalian red cells have no nucleus and thus no DNA in the red cells. To clone a mammal, you must find a white cell, which is much rarer than red cells, but dinosaurs have nucleated red cells, as do modern birds. It is one of the many indications we have that dinosaurs aren't really reptiles at all. They are big, leathery birds. Tim saw that Grant still looked skeptical, and Dennis Nedry, the messy fat man, appeared completely uninterested. As he knew it already, Nedry kept looking impatiently towards the next room. I see Mr. Nedry was spotted the next phase of our work, Wu said. How we identify the DNA we have extracted. For that, we use powerful computers. This is our high-tech Landroman, Dr. Wu said. The boxes along the wall are the Hamachi Hood automatic gene sequencers. They're being run at very high speed by the Gray XMP supercomputers, which are the towers in the center of the room. In essence, you're standing in the middle of an incredible powerful genetic factory. There were several monitors, all running so fast it was hard to see what they were showing. Wu pushed a button and slowed one image. Here you see the actual structure of a small fragment of dinosaur DNA. Notice the sequence is made up of 4 base compounds: adenine, thymine, guanine, and cytosine. This amount of DNA probably contains instructions to make a single protein, say a hormone or an enzyme. The full DNA molecules contain 3 billion of these bases. If you look at the screen like this once a second, for 8 hours a day, it takes more than 2 years to look at an entire DNA strand. It's that big. This is a typical example because you see the DNA has an error. Down here, the line 1201. Much of the DNA we extracted is fragmented or incompleted. So the first thing we have to do is repair it. Or rather, the computer has to. It'll cut the DNA using what are called restriction enzymes. The computer will select the various of enzymes that might do the job. Here's the same section of DNA with the points of restriction enzyme located. As you can see in the line 1201, two enzymes will cut on either side of the damage point. Ordinarily, we let the computer decide which to use. But we also need to know what base pairs we should insert to repair the injury. For that, we had to inline various cut fragments like so. Now we're finding the fragment of DNA that overlaps the injury area and will tell us what is missing, and you can see we can find it, and go ahead and make the repair. The dark bars you saw are the restriction fragments, small section of dinosaur DNA, broken by enzyme, and then analyzed. The computer is now recombining them by searching for overlapping sections of codes. It's a little like putting puzzles together. The computer can do it very rapidly. And here is the revised DNA strand, repaired by the computer. The operation you have witnessed would have taken months to a conventional lab, but we can do it in seconds. Then you are working with an entire DNA strand, Grant asked. Oh no, that's impossible. We have come a long way from the 60s, when it took a whole laboratory 4 years to decode a screen like this. Now the computers can do it in a couple of hours. But even so, the DNA molecules is too big. We looked only at the section of the strand that differ from animal to animal, or from contemporary DNA. Only a few percent of the nucleotides differ from one species to the next. That's what we analyzed, and it's still a big job.
Dennis Nedry yawned. He'd long ago concluded that InGen must be doing something like this. A couple of years earlier, when InGen had hired Nedry to design the park control systems, one of the initial design parameters called for data records with 3 by 10 to the 9th fields. Nedry just assumed that was a mistake, and had called Palo Alto to verify it, but they had told him the spec was correct. 3 billion fields. Nedry had worked on a lot of large systems. He'd made a name for himself, setting up worldwide telephone communications for multinational corporations. Often those systems had millions of records. He was used to that. But InGen wanted something so much larger. Puzzled, Nedry had gone to see Barney Fellows over at Symbolics near the MIT campus in Cambridge.
What kind of a database has 3 billion records, Barney?
A mistake, Barney said, laughing. They put in an extra 0 or 2.
It's not a mistake, I checked. It's what they want.
But that's crazy, Barney said. It's not workable. Even if you had the fastest processors and blindingly fast algorithms, a search would still take days, maybe weeks.
Yeah, I know. Fortunately, I'm not being asked to do algorithms. I'm just being asked to reserve storage and memory for the overrail system. But still, what could the database be for?
Barney frowned. You operating under an ND?
Yes, Nedry said. Most of his job requires non-disclosure agreements.
Can you tell me anything?
It's a bioengineering firm.
Bioengineering, Barney said. Well, there's the obvious.
Which is?
A DNA molecule.
Oh, come on, Nedry said. Nobody could be analyzing a DNA molecule.
He knew biologists were talking about the Human Genome Project to analyze a complete human DNA strand, but that would take 10 years of coordinated effort, involving laboratories around the world. It was an enormous undertaking. Manhattan Project, which made the atomic bomb.
This is a private company, Nedry said.
With 3 billion records, Barney said, I don't know what else it could be. Maybe they're being optimistic designing their system.
Very optimistic, Nedry said.
Or maybe they're just analyzing DNA fragments, but they've got RAM-intensive algorithms. That made more sense. Certain database search techniques ate up a lot of memory. You know who did their algorithms?
No, Nedry said. This company is very secretive.
Well, my guess is they're doing something with DNA, Barney said. What's the system?
Multi-XMP.
Multi-XMP? You mean more than one, Cray? Wow. Barney was frowning now, thinking that one over. Can you tell me anything else?
Sorry, Nedry said. I can't.
and he had gone back and designed the control systems. It had taken him and his programming team more than a year, and it was especially difficult because the company wouldn't ever tell him what the subsystems were for. The instructions were simply, design a module for record-keeping, or design a module for visual display, but no details about use. He had been working in the dark. And now that the system was up and running, he wasn't surprised to learn there were bugs. What did they expect? And they'd ordered him down here in a panic, all hot and bothered about his bugs. It was annoying, Nedry thought. Nedry turned back to the group as Grant asked,
And once the computer has analyzed the DNA, how do you know what animal it encodes? We have two procedures, Wu said. The first is phylogenetic mapping. DNA evolves over time, like everything else in an organism, hands or feet or any other physical attribute. So we can take an unknown piece of a DNA and determine roughly by computer whether it fits in the evolutionary sequence. It's time-consuming, but it can be done. And the other way? Wu shrugged. Just grow it and find out what it is, he said. That's what we usually do. I'll show you how that's accomplished. Tim felt a growing impatience as the tour continued. He liked technical things, but even so, he was losing interest. They came to the next door, which was marked fertilization. Dr. Wu unlocked the door with his security card, and they went inside. Tim saw still another room with technicians working at microscopes. In the back was a section entirely lit by blue ultraviolet light. Dr. Wu explained that their DNA work required the interruptions of cellular mitosis at precise instant, and therefore they kept some of the most variable poisons in the world. Helotoxins, colchicinoids, beta-alkaloids, he said, pointing to a series of syringes set on under the UV light. Kill any living animal within a second or two. Lex was bored. Nedry was yawning, and even Dr. Sattler was losing interest. Tim was tired of looking at these complicated laboratories. He wanted to see the dinosaurs. The next room was labeled hatchery. It's a little warm and damp in here. We keep it at a 99 Fahrenheit and related humidity of 100%. We also run on a higher O2 concentration. It's up to 33%. Jurassic atmosphere, Grant said. Yes, at least we presume so. If any of you feel faint, just tell me. Just a reminder, don't touch anything in this room. Some of the eggs are permitted to skin oils. And watch your heads. The sensors are always moving. He opened the inner door to the nursery, and they went inside. Tim faced a vast open room, bathed in a deep infrared light. The eggs lay on the long tables, their pale outlines obscured by the hissing low mist that covered the tables. The eggs were all moving gently, rocking. Egg reptiles contain large amount of yolk, but no water at all. The embryos must extract water from the surrounding environment, hence the mist. In this hatchery, we have produced more than a dozen crops of extractions, giving us a total of 238 live animals. Our survival rate is somewhere around 0.4%, and we naturally want to improve that. But by computer analysis, we're working with something like 500 variables, 120 environmental, another 200 intra-egg, and the rest from the genetic material itself. Our eggs are plastic. The embryos are mechanically inserted, and then hatch here. And how long to grow? Dinosaurs mature rapidly, attaining full size in 2 to 4 years. So we now have a number of adult specimens in the park. What do the numbers mean? Those codes identify the various batch extractions of DNA. The first 4 letters identify the animals being grown. Over there, that trike means Triceratops, and the steg means Stegosaur, and so on. And this table here? Grant said. That's a new batch of DNA, Wu said. We don't know exactly what will grow out. The first time an extraction is done, we don't know for sure what the animal is. You can see it's marked presumed coiling, so it is likely to be a Coelurosaurus, a small herbivore, if I remember. It's hard for me to keep track of the numbers. There are something like 300 in Gennaro of dinosaurs known so far. 347? Tim said. Grant smiled. Is anything hatching now? Not at the moment. The incubation period varies with each animal, but in general it runs about 2 months. We tried to stagger hatchings to make less work for the nursery staff. You can imagine how it is when we have 150 animals born within a few days. Though, of course, most don't survive. Actually, these eggs are due any day now. Any other questions? No? Then we'll go to the nursery, where the newborns are. What have we got here, Kathy? Dr. Wu asked. Not much, she said. Just a baby raptor. Let's have a look. It looks like a lizard. The animal on the floor was about 1.5 feet long, the size of a small monkey. It was dark yellow with brown stripes like a tiger. It had a lizard's head and a long snout, but it stood upright on strong hind legs, balancing by a thick straight tail. Its small front legs waved in the air. It cocked its head to one side and peered at the visitors staring down at it. Velociraptor. Velociraptor mongoliensis, Wu said, nodding. A predator. This one's only 6 weeks old. I just excavated a raptor, Grant said as he bent down for a closer look. Immediately, the little lizard sprung up, leaping over Grant's head into Tim's arms. Hey! They can jump, Wu said. The babies can jump. So can the adults, as a matter of fact. Tim caught the velociraptor and held it to him. The little animal didn't weigh very much, a pound or two. The skin was warm and completely dry. The little head was inches from Tim's face, its dark baby eyes staring at him, a small forked tongue flicked in and out. Will he hurt me? No, she's friendly. Are you sure about that? Oh, quite certain, at least until she's grown a little older. But in any case, the babies don't have any teeth, even egg tooth. Egg teeth? Nedry said. Most dinosaurs are born with egg teeth. Little horns on the tip of the nose, like rhinos' horns, to help them break out of the eggs, but raptors aren't. They poke a hole in the egg with their pointed snout, and then the nursery staff has to help them out. You have to help them out? Grant said, shaking his head. What happens in the wild? In the wild? When they bred in the wild. When they make a nest. Oh, they can't do that, Wu said. None of our animals is capable of breeding. That's why we have this nursery. It's the only way to replace stock in Jurassic Park. Why can't the animals breed? Well, as you can imagine, it's important that they not be able to breed, Wu said. Even when we face a critical matter such as this, we design redundant systems. That is, we always arrange at least 2 control procedures. In this case, there are 2 independent reasons why the animals can't breed. First of all, they're sterilized, because we irradiated them with X-rays. And the second reason? All the animals in Jurassic Park are female, Wu said with a pleasant smile. I should like some classifications about this, because it seems to me that irradiation is fraught with uncertainty. The radiation dose may be wrong, or aim at the wrong anatomical areas of the animal. All true, Wu said, but we're quite confident we have destroyed the genital tissues. And as for them all being females, Malcom said, is that checked? Does anyone go out and lift the dinosaur's skirts to have a look? I mean, how does one determine the sex of a dinosaur anyway? Sex organs vary with the species. It's easy to tell on some plain on others. But to answer your question, the reason we know all the animals are female is that we literally make them that way. We control their chromosomes, and we control the intra-egg development environment. From a bioengineering standpoint, females are easy to breed. You probably know that all vertebrate embryos are inherently female. We all start life as females. It takes some kind of adding effect, such as a hormone at the right moment during development to transform the growing embryo into a male, but left to its own device, the embryo will naturally become female. So our animals are all female. We tended to refer to some of them as males, such as the Tyrannosaurus Rex. We call it a him, but in fact, they're all female. And believe me, they can't breed. The little velociraptor sniffed at Tim and then rubbed her head against his neck. She wants you to feed her, Wu said. What does she eat? Mice. But she's just eaten, so we won't feed her again for a while. The little raptor leaned back, stared at Tim, and wiggled its forearms into the air. Tim saw the small claw on the 3 fingers each hand. Then the raptor burrowed her head against his neck again. Grant came over and peered critically at the creature. He touched the tiny 3-clawed hand. Do you mind? And Tim released the raptor into his hands. She doesn't like that, Regis said. don't like to be held away from body contact. Dr. Grant, if you please. I'm not hurting her. Dr. Grant, these creatures are not from our world. They come from a time where there are no human beings around to prod and poke them. I'm not proning it, Dr. Grant. Put her down, Ed Regis said. But now! Grant handed the animal back to Tim. It stopped squealing. Tim could feel its little heart beating rapidly against his chest. Tim petted the little raptor. It's okay, kid. Everything's fine now. The heart was still beating rapidly. We feel it's important that the animals here be treated in the most humane manner, Regis said. I promise you that you will have every opportunity to examine them later. But Grant couldn't stay away. He again moved towards the animal in Tim's arms, peering at it. Fascinating, Grant said. Can I stay and play with her? Tim said. Not right now, Ed Regis said, glancing at his watch. It's 3 o'clock, and it's a good time for a tour of the park itself, so you can see the dinosaurs in the habitats we had designed for them. Tim released the velociraptor, which scrambled across the room, grabbed a cloth rag, putting it in her mouth, and tugged at the end with her tiny claws.